Hello, good morning. Today, what I'd like to look at is earthing. And what we're looking at, earthing and bonding. And we're going to be looking at earthing and bonding 1, okay? Session 4. Now, this is for the video which you will need to look at that tells you about earthing and bonding. Okay? Okay. And again, we're looking at city and guilds. Now, it's important that, again, you are compliant with the IE regulations. You must look at equipotential bonding, how that applies to yourself in today's installation work. So make sure that you're compliant. Look for the guide, use those notes and references to forth. Okay. Again, be sure that you are compliant at all times with the IEE regulations in regard to earthing and bonding. Now, what I'm going to show you, or when you look at the video, what you'll see is that it was applicable at the point in time up to the 17th edition, basically. But now we're looking at the 18th and 19th edition of the IE regs. So that is something you need to consider when you're looking at these videos, okay? All right, let me just bear with me while I get to work. Okay, what am I looking at here? Okay. It's okay, these send me messages at the wrong time. That's per normal. Okay. Ah, let's see if we can get you into play. Okay. Yeah, I think we are in play now, basically, yeah. Okay. Earthing and bonding, session 1, well, not session 1, sorry. Session 4, earthing and bonding 1, okay? Now, the reason why I've said 1 is because there are 2 videos which will be produced in regards to earthing, because it was a lot to put onto one video. So I have decided to put it onto 2. I don't know why I keep saying we, but it's just me one. But I suppose we come in to the family of electrical engineers who are probably out there now working very hard. Okay? Right. Session 4, Earthing and Bonding 1. Aims and objectives of this session: to be able to differentiate between the terms earthing and bonding, to be able to give example of each. Right, this is all revision you look at open circuits, support, it's all there. Mean of calling is a switch that makes a circuit, etc., etc., etc. I don't need to read that out to you. You should be able to read it for yourselves, okay? And I'm hoping that that is correct. Yes. Make sure that, 1 second, make sure I pan back, get it all in, okay? What is Earth? The whole of the world may be considered as a vast conductor, which somebody's bugging me here. Let me just check something. It's okay. I'm looking because I'm reading something here and I felt like I have read it previously before. Okay. Okay. Quite odd. Okay, I'm going to run it and see anyway. See what I come up with. Back to where it was. Okay. Let's stop here. Okay, I thought I had done this already at the video, but I couldn't find the video there. So quite possibly I didn't do it as I thought I had done. Okay, so. Okay. Right, let me just go back a little bit. Right, Sitting Guild's certificate in electrotechnical technology. Session 4, Earthing and Bonding 1. I repeat, Earthing and Bonding 1. Aimed and objective of this session to be able to differentiate between terms earthing and bonding, to be able to give example of each. Okay, let's just get on with it then. Okay, revision, that's, you've covered that already previously. Okay, so you should have done. That's for you to read. Okay. What is Earth? The whole of the world may be considered as a vast conductor which is at reference zero potential. Potential here being the difference between two voltages. People are usually more or less in contact with Earth, so if other parts which are open to touch become charged at a different voltage from Earth, a shock hazard exists. Some types of soil make a poor Earth, symbol for Earth. Okay. Potential differences. You can see that we have a potential difference. When we have a voltage of potential difference of 230 volts, we have raised the voltage to 230 volts above zero. Okay, and here's our diagram that shows this. Voltages can also be raised above another voltage, so it is important to all reference point. Now the start point, now the delta side of your transformer has no center tapping point. It's just main, it's just incoming mains, etc. Okay, but the star side has a center tapping point. Okay, the start point of the supply authority transformer on the secondary side is connected to earth, which is accepted as being 0 volts. The primary of the supply authorities transformer H3 has an earth provided, and this is connected to the structure of the transformer. Okay. Earth fault loop path. Now, the earth loop is the path which begins at the fault, passes through the earth conductor, then into the submain, and then back to the point of the fault. Okay, but within that area of the fault occurring here, and you can see the path that it follows, the fuse current should sufficiently be large enough to operate the protective device. That is why we have the protective device, the circuit breaker, or the fuse. So if you have a short circuit there, that the current immediately is so large that it trips or operates a protective device. This is essential because it protects the cable from damage. Because if you get excessive current going through the cable, and it may be a 2.5 cable, you will cause the conductor to change structure, and therefore you will need to run a new cabling. Okay, so it protects the circuit essentially. Reason for providing earth and bonding in an installation: sufficient current should flow under an earth fault so that the protective device, fuse, or a circuit breaker operates within a predefined time. While the fault exists, metalwork could rise to a high potential. Bonding occurs to enable exposed and extraneous metalwork to be linked together. This gives us an equipotential bonding zone. Exposed conductive parts. Now, an exposed conductive part is a conductive part of equipment which can be touched and which is not a live part but may become live under fault conditions. Okay? So anything that is exposed, your cooker, your trunking installation, so forth, just because something is metal, it doesn't mean that it is necessarily needs bonding. Okay, but where it becomes part of anything that is a potential hazard, then it should be bonded. Okay, and again, confirm bonding conditions in regards to the IEE regulations. You must comply with that at all points in time. So check, 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 and check again. Okay, be compliant. A potential, generally an earth potential, and not forming part of the electrical installation. Your gas, your water, etc. Now, be aware because some mains coming into the property now is plastic, and some houses are now being wired in plastic. If any metal comes out of the ground and we can assume the ground is at earth potential, then that metal work is an extraneous or conductive part. Circuit protective conductors, CPC, okay? BS7671. Now, again, make sure you're dealing with the current BS7671, the 18th or 19th edition. This would refer to the 17th, maybe the 16th edition. So be aware that you are up to date. A protective conductor connecting conductive parts of equipment to the main earthing terminal. Okay. Make sure that is still the relevant definition in regards to BS7671. Circuit protective conductor, CPC. A circuit protective conductor can be a single core cable, a conductor in a cable, an insulated or bare conductor, a fixed bare or insulated conductor, a metal covering such as the arm ring for cable, a metal conduit, an extraneous conductive part whose continuity can be guaranteed. Okay. Okay, I hope you found this useful. I'll leave it here now for now, and I'll pick it back up later on. Thank you. Okay. Okay, in stream, yeah, leave it. I will